Hello everyone, welcome to this channel. If you're new here, my name is Muhammad Hasan. Let's begin our 10th part of the video series. In this video, I'll be discussing the concept of shifting of object due to glass slab. So first I will do that. I'll derive the formula so that you can use that formula directly and find the shifting of object due to slab. Then I'll complicate the scenario by increasing the number of glass slab, and then we will find again if the number of glass slab is more than one, then how to find the shifting of object or how much will be the object shift. So that will be our second task, and then we will move into lateral displacement due to glass slab. Okay, so we'll be dealing with lateral displacement after that, and then finally I will give you a numerical based on lateral displacement that will help you to solidify the concept of lateral displacement. So this is all about the concept that we'll be dealing today. So let's begin our video and let's enjoy. But before that, let me roll the intro. Okay, now we'll be looking into this concept of shifting of object due to slab. We'll be learning two things here. That is, one is shifting of object due to slab, another is lateral displacement. So let's start with this and see how much will be the shift of object due to a slab. And that slab can be made up of glass or maybe of any material. The formula will remain the same, okay? So let's see what will be the formula, direct formula, in order to find out the shifting of object due to a slab, a rectangular slab. So let's see. This is very simple. The concept of real depth and apparent depth have already been explained in my earlier video. So if you haven't gone through that video, then it will be difficult for you. But if you have gone through that video, then this is just a piece of cake. Very easy. So let's see how to solve this kind of question. See, the object is kept here, as you can see. Okay. And we'll be looking into this object from the other side of the slab from here, suppose, maybe. This is our eye, okay? Now, how much will be the object shift? That is our task. So let's see how to do that. Now, this is a glass, okay, having refractive index mu given, and this is air. We know the refractive index of air is 1. The thickness of the glass is given to be T, and the object is kept at a distance x from the surface of the slab, okay? So these are the given conditions. Now let's see what happens. Now we know that glass is optically denser than air. Therefore, what will happen? A ray of light will go from here and will fall on the interface between air and glass. And then what will happen? Will it go towards the normal or away from the normal? We know since glass is optically denser than air, therefore the rays will bend towards the normal. So if this is our normal, then it will bend in this fashion, isn't it? Now, if we keep our eye here in this glass medium, okay, then what will happen? Then our brain will trick us and will tell us that the object is somewhere here. If we backtrack the rays, see, we won't see the rays bending. Our brain is programmed in such a way that it will always see that the light is coming in a straight line. Okay, so if we just extend that ray, then we will get the object somewhere here. And this is how our brain will interpret that the object is there. Okay, this is clear. But now we are seeing it from this position, okay, in this medium. So what will happen now? Let's see. Now we know that air is optically rarer than glass. So the rays come here and incidence on this interface. Now since it is entering into optically rarer medium, now this is our normal. So it will bend away from the normal, isn't it? Therefore, if we extend this, then we will see that the object is formed here. If we observe the object from this medium, okay, this is our eye. So simple as that. This is how we will observe. Now our question is, find the shift of object due to the slab. How much is the shift? That is, we need to calculate this distance. How much is the shift from the original position? Now how to do that? Now you can solve this by the technique that I have shown you in my earlier video. That is, let me explain and derive the expression. So we know that mu2 by mu1 is equal to real depth by apparent depth, isn't it? This thing have already been discussed and been proved earlier. So mu2 by mu1 is equal to real depth by apparent depth. But we need to understand what is mu2. Mu2 is the medium in which the object is kept, whose apparent depth we need to find out, isn't it? So mu2 here, the object is kept in air medium, isn't it? Therefore, mu2 is nothing but mu of air divided by mu of glass, because we are seeing it from the glass medium in the first case. See, understand, the last thing that I've discussed in my earlier video, the last part of the video, where I said that when there are combination of medium, like we can see that there are two combination here for real depth and apparent depth, we only deal with two medium. Okay, but here we can see this is one medium, this is one medium, again this is another medium, so we are getting two combination. One is air glass, another is glass air. So what we will do, we'll first solve with this one and then we will solve with this one. Okay, so simple as that. So first of all we will take combination air and glass, that is air and glass. We will be solving for this one. Okay, so in that case we know that mu2 is equal to air and mu1 is that of glass. So real depth we can see it's given, it is x, and apparent depth we need to find out d dash. So we can see that d dash will be x, mu of glass is given as mu, therefore it became mu, and mu of air we know it's 1. Therefore the apparent depth d dash is equal to x mu. Simple. So this, the object that is formed here, the apparent depth is actually x mu. Okay, so this distance from this interface to this is actually x mu. I hope this is clear. This is the apparent depth. It was actually, the actual depth is x, but the apparent depth is x mu. This is what we got. But this is not what our target is. Our target is we want to see the object from this medium, from air medium. So let's see how to solve that. Now this object will act as virtual object for the second combination. Easy. Now let's solve it again. Now we will be taking into consideration glass and air. Okay, this is the combination. So again mu2 by mu1 is equal to real depth. Now real depth here is how much? See, the thickness is t, because we are calculating from this this interface, isn't it? So t plus x mu. Now the object is there, so the real depth is t plus x mu divided by apparent depth. We need to find out. Now mu2, what will be the mu2? The object is kept in this side, okay, not in air. Therefore the mu2 will be refractive index of glass. So refractive index of glass is given as mu, and refractive index mu1 of air is 1. Therefore mu is equal to t plus x mu by d dash. Therefore we can say that apparent depth is equal to t plus x mu divided by mu. Okay, we will look into this diagram. This is the object that we are getting when we are seeing it from the air medium. Okay, from this side. Simple as that. Let me pick another color. Therefore the apparent depth that we got, that is from this interface to this, is actually t plus x mu by mu. Okay, simple. But we need to find out shift of object. How to find out the shift of object? Now let's see. Shift is equal to, very simple, we know the shift is this much, isn't it? We know this distance and we know this distance. Okay, therefore we can easily find out the shift. Okay, so if this is suppose a and this is suppose b, the distance, then shift will be a minus b. Shift will be a minus b. Simple. Now we know what is a. A is x plus t. A is x plus t. Simple. And b is, again, b we have found out, t plus x mu divided by mu. Simple. Now if you solve this, very easy. If you solve this, then we are going to get t into 1 minus 1 by mu. Okay, so this is the shift of object due to slab. Now you need to remember this formula, that is the shift. Okay, just you need to remember that this will work only when the medium this side and the medium on the other side has to be equal. The medium on this side and the medium on this side has to be same. If it is air, then that side should be air. If this side is suppose water, then the other side should be water. Okay, both of the mediums should be same, then only this kind of formula will work. Now there are certain key points which we need to understand from this formula. Now this is the formula. Now a smart student will not only remember this formula, but they will dissect this formula in order to solve some tricky questions. Okay, now our next task is to dissect this formula and see what are the conclusions that we can derive from this formula. Okay, now we'll look into that. So let's move on. Now let's look into the keynotes from the above formula that we have derived. Basically, we will be dissecting the formula. So the formula was S, that is shift, is equal to T multiplied by 1 minus 1 by mu, where mu was the refractive index of the glass slab that we have used, or it can be any material by which the slab is made up of. Okay, so this was the formula. Now let's see into our first point. It says that this formula will work only when the rays are paraaxial. Now let's understand what does paraaxial means. Now the term is new, but I have already explained this. Now, when we were discussing about real depth and apparent depth in our previous video, and I was deriving the formula mu2 by mu1 is equal to real depth by apparent depth, there I have, while I was deriving that derivation, then I said that there's an assumption for this formula to work, and the assumption was, if you remember, that means you're paying attention to the lectures. Okay, if you don't remember, I'll tell it again. The assumption that we made was sine theta is equal to tan theta is equal to theta when theta is equal to small. Now theta is small when the angle is very small. Then only we take sine theta is equal to tan theta is equal to theta, isn't it? That is, we are saying that sine theta is equal to tan theta is equal to theta. This will occur only when theta is very small. Now theta is small only when, suppose this is our interface, this is our normal, then when the angle, that is the angle of incidence, is very much perpendicular to the interface, isn't it? Not fully perpendicular, but almost perpendicular. That is, if the normal is the axis, it is almost parallel to the axis. Therefore, if it is almost parallel to the axis, then theta will be very small. In that case, we say that kind of rays are paraaxial. Okay, simple as that. And since we are using the concept of real depth and apparent depth here to find out the formula, therefore again that assumption will come into play. Okay, so we can say that theta should be small, or we can simply say rays should be paraaxial. Okay, simple as that. Now number 2, both sides of the slab should have same medium. Now if this is the slab having refractive index mu and can be of any material, the surrounding material this side and the surrounding material this side should be same for this kind of formula to work. The second point is done. Now number 3, it says that if the surrounding material is not air, that is, it is different from air, we have derived that. Let me rub this in order to explain the thing. So we have got that S, when it is surrounded by air, the slab is surrounded by air, then it is T, that is thickness of the slab, into 1 minus 1 by mu, that is mu is the refractive index of the slab. Now this formula will work only when the surrounding material is air. But if the surrounding material is not air, you need to use this formula. It is very simple, like S is equal to 2 into 1 minus mu of surrounding by mu of slab. See, here it was 1 because we know mu of air is equal to 1. Instead of this, just replace this mu of air with mu of surrounding and you'll get the answer. Okay, this is simple. Now let's look into our 4th point. The distance at which the object is placed from the slab doesn't matter. Again, let me write the formula. S is equal to T into 1 minus mu of surrounding by mu of slab. Now if you look into this formula, then you'll see that there is no mention of distance of the object from the slab. Let me go back and show you this diagram. If you look into this diagram of the slab, we will see that this is the object, isn't it? This is the object and it is placed at a distance x. But when we derive the formula here, there is no parameter of x here. There is no parameter of x. It doesn't matter whether it is x meter or y meter or x centimeter, y centimeter. It doesn't matter. Shift will be T into 1 minus mu of surrounding by mu of the slab. Simple as that. So this is the thing that we got from the formula, and the last one is the sign of the shift. Sometimes when we solve MCQ, you'll see that S will have positive value and sometimes S will have negative value. Now what does this positive value and negative value suggest? It's very simple. If the shift is positive, then that means the shift is happening along the direction of incident ray. Don't worry, I'll explain. Let me rub this and draw this slab. Okay, now the object is kept here. Okay, now we are watching the object from this part. Okay, so the incident ray will come from here and then it will enter our eyes by refraction. So I'm not drawing that. So the direction of incident ray is this one. Okay, So we can say that this direction is taken as positive and the opposite direction will be taken as negative. So if our body is shifted in this direction, then we will say the shift is positive. If our body is shifted this side, then we will say that shift is against the direction of incident ray. Okay, so this is what S is equal to positive and S is equal to negative actually means. So these are the concepts or the important points that you need to remember for this kind of formula. Okay, so I hope the concept is clear. Now they can ask objective based on these key points sometime in NEET, but if they ask, then it's easy because I've written down in bullet points. There are 5 points. If you just remember these 5 points, then everything is simple from this part. Okay, so let's move on. Okay, now let's look into this problem and see how to solve this kind of problem very quickly. Okay, earlier we have done the shifting of object by a slab that was a single slab. Okay, now what we have done is there are a combination of slab. There may be 3, there may be 2, there may be 4. Doesn't matter. You just need to understand the concept and things will be easy. Okay, if you just follow the traditional way, then it's very difficult to solve this question. Okay, it will take around 1 hour. Maybe for you people. So what can we do in order to solve this question within like 1 minute? Let's see. Now if you use the traditional method, then what we'll do, you'll take each pair, like this is 1 and 2, this is a different medium, and again this is a different medium. Now you'll be using n2 by n1 is equal to real depth by apparent depth, and you'll find out the apparent depth. Then that position you'll be using as the virtual object, and now you'll be taking this medium and this medium, and again use n2 by n1 and real depth by apparent depth. After that you'll get the apparent depth for this part. Then again you'll be doing that for this, and again after that you'll be using this and this. After that you'll be using this and this pair, and at the end you'll be using this and this pair to get the final result. So it's a very long process. Okay, now if they give 4 to 5 slab, then it's gone. Like you'll need 1 hour to solve that, and there's no guarantee that you can solve that. If there is a silly mistake in between, then your time is gone and your mark is also gone. So what to do in order to save ourselves? So it's very easy. Now let's understand the easy concept. What we can do is, since there are 3 slab, so the shifting will be done by this slab, the shifting will be done by this slab, and the shifting will be done by this slab. And we know the formula that shifting by a single slab is T 1 minus, if it is air, then 1 by mu, where mu is the refractive index of the slab material. Okay, so this is the simple thing. Now if there are 3 slab, what we'll do is first find the shifting due to first slab, and then we'll be doing it for the second slab, and then we'll be doing it for the third slab, and finally the final shift what will be is equal to S1 plus S2 plus S3. Now how to find S1, S2 and S3? Simple. See, we'll be using this formula only. T is what? The thickness of the first slab, and 1 minus 1 by mu, and mu is the refractive index of the first slab. Okay, now for the second it will be thickness of the second, and 1 minus 1 by mu 2, and for the third slab, thickness of the third, 1 minus 1 by refractive index of the third material of the slab. So this is how you need to do. Simple, just add this and you'll get it. Now the thing that you need to remember is, let's write down in bullets. The first thing is distance between the slab doesn't matter. So what is the distance? Whether here it is 10 centimeter, 10 centimeter. If it were like 20 centimeter and 15 centimeter, then doesn't matter. It won't change the value of the shift. Okay, so that's what I'm trying to say, that distance between the slab doesn't matter. And number 2 is the medium between the slab. Okay, so the medium between the slab doesn't matter. We just need to look what is the initial medium and what is the final medium. Okay, we just need to look into this, and this medium and this medium has to be same. We have discussed earlier, and we don't need to look into this medium and this medium. Okay, we just require this. What is the medium used here? Since air is being used, so we have used 1 in every case. Okay, If other material was used, like for example a different medium like water, and then this side should also be water, then we would have used here mu of water in every case. Okay, I hope this much is clear. If this is clear, then things are easy. Now if I solve S1 using the formula, then it will be T1, we know it's 30 centimeter, and 1 minus, since it is air, 1 by mu1 is 1.5. if you solve this, we are going to get 10 centimeter plus 10. Okay, for S2, if we solve again, so thickness is 20 centimeter, 1 minus 1 by refractive index of the second material is 2. So if we solve this, we'll be getting again plus 10 centimeter. Okay, and for the third slab, if we solve again, then we'll get that T3, that is the thickness of the third slab, is 15 centimeter, and 1 minus 1 by refractive index of the third material is 1.5. so if we solve this, then we are going to get plus 5 centimeter. Now if we add, so the total shift is 10 plus 10 plus 5, so 25 centimeter is the total shift. Simple as that. So if you just remember the formula, the two things that you need to remember is this one: the distance between the slab doesn't matter, and second point is the medium between the slab doesn't matter. The only thing that matter is the initial and the final medium should be same, and then you can use the formula S is equal to T into 1 minus 1 by mu. Now I have used 1 here because the initial and the final material here and here it is air. If it is other material, then we'll be using refractive index of that material. Okay, so if you just use this concept, you can solve this question within 1 minute. Very simple. Okay, so that's all for this concept. I hope the concept related to shifting due to slab is clear. Now let's move on to our next concept, that is lateral displacement. Okay, so let's move on. Okay, now let's look into our final concept of this video, that is lateral displacement or lateral shift. Now how to calculate that? It's simple, just understand the figure and things will be easy. Okay, suppose this is a slab having refractive index mu, having thickness suppose small t. Okay, now we need to find out the lateral shift. Now what does lateral shift actually means? Just understand the ray diagram, it will be clear. So suppose a ray of light, suppose this ray of light falls on this interface between, suppose this is air and this is glass. Okay, fall at the interface of air glass medium at a certain angle of incidence I, and it is shown here by small I. That's the angle of incidence. Now after refraction, what will happen? Since the glass is optically denser than air, therefore after refraction the ray will move towards the normal, as you can see. So the ray has moved towards the normal. Therefore this angle is the angle of refraction as it is shown here, that is small r, angle of refraction. Now once it reaches the other end of the slab, again the ray will incident upon the interface between glass and air, okay, this point, and then what will happen? It will enter into air medium, and we know that air is optically rarer medium. As a result of which the ray will bend away from the normal, as you can see this. Okay, so this has bent away from the normal. Okay, so this is simple. Now if there was no glass slab, what would have happened is this ray, the blue ray that you can see, this will go and then it will follow the pink dotted line, as you can see this one, the pink dotted line, and it would have followed this path. But now we can see due to the glass slab, the ray has come out from this part. Okay, and both the rays are parallel. Therefore we can say that this ray has shifted sideways. Therefore this is known as lateral shift, because lateral means side way. Sideways, since the ray has moved sideways, therefore this is known as lateral shift. Okay, so the rays are parallel, the only thing that is different is that it has shifted a little bit. Okay, and this kind of shift is known as lateral shift. So the important thing that you need to remember is that the incoming rays and the outgoing rays are parallel. So I have written it down in star, the incoming rays and the outgoing rays are parallel. This is one of the important points. Now how to measure this lateral shift? As you can see here, this lateral shift, what is the magnitude of this lateral shift? How to calculate that? So let's understand the proof, and it's very easy. It's a two-line proof. So let's understand the ray diagram. Now we have marked some points like Q, O, this is R, this is U. Okay, we'll be playing with this point. Now if you look into the ray diagram and find out the triangle QRU. Okay, so this is the triangle QRU. So QR, and we have taken a perpendicular line. Okay, so this is the triangle QRU. Now if we analyze this triangle QRU and find out sine I minus R. Now let me explain that if this is angle I, then this whole thing will be angle I, and we know that this is angle R, therefore this angle will be I minus R. Therefore sine I minus R, if you look into the triangle QRU, then sine of I minus R is nothing but UR by QR. This is perpendicular and this is hypotenuse for the triangle. Now UR is the perpendicular, simple, and QR, this line, is actually the hypotenuse. So this is sine I minus R, and which is equal to UR by QR. Now if you look into the second triangle, that is triangle QOR. Okay, we'll be looking into this. So let's figure it out from this diagram. Q, O and R. This is the triangle. Simple as that. Now we will calculate cos R. Now we know the formula for cos. It is base by hypotenuse. Now if you look into the triangle, then QO is actually the base. This is the base. Okay, so that's the base, and QR is the hypotenuse. This is the hypotenuse for the triangle. Now once we have found out this, now what we will do is divide equation 1 by equation 2. Now we have got two equations, equation 1 and equation 2. Now once we divide equation 1 by equation 2, you will get UR by QO is equal to sine I minus R divided by cos R. And what happens is this QR and this QR will get cancelled out if you divide. Okay, now why we have done this? See, our target is to find the lateral displacement. Now let's look into the figure. If you look into this figure, you know this is the lateral displacement, and we have considered this triangle QRU, isn't it? If you look carefully, then this line, let me pick another color, white color. So this UR is basically the lateral shift here, isn't it? Simple. So our target is to find UR. Okay, now let's look into our equation. So our target is to find UR, and that is our lateral shift. So this is our lateral shift. Okay, so we can write it down here that this is actually the lateral shift. And QO, we have brought QO this side. So if you look into the figure again, QO is nothing but the thickness of the slab. So let's move up. See, this is Q and this is O. So QO is this, and this is nothing but the thickness of the slab, isn't it? So simple as that. So replace QO by thickness of the slab, that is small t, and we got that lateral shift, that is L, is nothing but thickness of the slab multiplied by sine I minus R divided by cos R, where I is angle of incidence and R is angle of refraction. So you need to remember this formula. See, they will ask question directly from this formula, but the challenging thing is that you need to remember this formula. Remembering these formulas are difficult. Okay, so after going through all 25-26 chapters, it's difficult to retain this formula. So they will ask question directly based on the formula. So if you can remember the formula, you can solve these questions easily. But what I will do is I will give you one difficult sum, complex sum from this part, so that your concept regarding this lateral shift is absolutely clear. Okay, now let's move into our numerical problem so that it will help us to solidify the concept that we have learned now. Okay, so let's move on. Okay, now let's look into this question. It says light passes through a glass plate of thickness d and refractive index mu. For a small angle of incidence theta, the lateral displacement is. And this question was asked in AIMS 2007, and it's based on the concept of lateral displacement. So let's see how to solve this question, and this is very easy. You can try it by pausing the video. So let's see. We know that lateral displacement, the formula is thickness multiplied by sine I minus r divided by cos r, isn't it? You need to remember this formula. But in this question, a condition is given, that is the small angle of incidence. It says that the angle of incidence is theta, which is very small. So how to deal with that? Let's see. Now thickness in this question is given to be d, and we know since angle of incidence, so thickness is given to be d and angle of incidence is given to be theta, and refractive index given is mu. Now this theta is very small. We know that when theta is very small, we can write this as theta for theta tending to 0, that is very small. Okay, now we can say that t will be d, and sine I minus r, since I minus r, this is the theta I minus r, since I is very small, therefore I minus r will also be very small. Therefore we can directly write sine I minus r as I minus r. And if angle of incidence I is small, okay, which is theta, then absolutely r will also be small, very small, isn't it? We know that for small angle, cos of theta is equal to 1 for theta very small, that is theta tending to 0. This is the concept, mathematical concept. So we can say that since r is small, this cos r will be equal to 1, okay, from this concept. This much is clear. If this is clear, then the sum is very easy. So d I minus r, I can be written as theta minus r. But if you look into the option, then there is no parameter called r here. You can check all the options and you'll see that there is no r present. So we need to replace this parameter r in terms of refractive index mu. So how to do that? We know that sine I by sine r is equal to mu, isn't it? Now here sine I is theta, and theta is very small, so we can write that sine theta by sine r is mu, or we can say that since theta is small, then it will become sine theta can be written as theta, and if theta is small, then r will also be small. Therefore we can write that sine of r is r, which is equal to mu, or we can say that r is equal to theta by mu, isn't it? Once we have solved this, r is equal to theta by mu, then it's very easy. We can write it from here that lateral displacement will be d theta minus theta by mu. Okay, now if we solve this, then we will get d theta 1 minus 1 by mu. Again, if you solve this, then we will get d theta mu minus 1 by mu. So this is our answer. This is the lateral displacement, and if you look into the option, then option 4 is the answer here. So simple, just use the formula. But I have given this question in order to explain this concept to you, that when theta is small, then sine theta is treated as theta. This is the condition. And for cos theta, when theta is small, then we treat cos theta as 1. Okay, so these are the concepts that you need to keep in mind. Okay, so whenever theta is small, then you need to use this concept. Otherwise the problem is very easy. You just need to use the formula of lateral displacement, that is thickness into sine I minus r, where I is the angle of incidence, r is the angle of refraction, divided by cos r, where r is the angle of refraction. So this is simple. I hope you have understood the concept. So just remember this formula and you can solve any question based on this concept. Okay, this is all for this video. I hope you enjoyed the concept, and all those concept that I explained was super simple. And oh, you guys are here. So if you enjoyed this video, then please give it a thumbs up, and if you haven't subscribed to this channel, then please consider doing so. Till next time, enjoy your studies and build your concept, and I will catch you all in my next video. Bye bye.